Molten metal sparks ignite instantly. The Magnesium Tab Igniter project dives deep into transforming ordinary aluminum soda can tabs into a powerful fire-starting apparatus. An unexpected journey from beverage waste to controlled combustion. Imagine collecting hundreds of these shiny tabs, perhaps 250 to begin, and carefully extracting any trace amounts of magnesium, often found as an alloy or a thin coating, a process requiring precision and patience. The first step involves concept realization, understanding that while most tabs are aluminum, some contain vital magnesium, a metal with an ignition temperature around 650 degrees Celsius. Crafting this soda tab igniter demands a methodical approach. First, painstakingly scraping or filing the internal surfaces of perhaps 25 individual tabs to gather a minuscule but potent pile of magnesium shavings. This raw material, sometimes just a mere 0.3 grams, is then carefully consolidated, perhaps by compacting it into a small disc or attaching it to a larger piece of tinder, like cotton, for better handling. Different methods are explored for collection one, involving dry scraping. Another, utilizing light abrasion techniques to maximize yield. The actual igniter construction might then involve encasing this prepared magnesium within a small protective shell or a modified tab section, ensuring it is ready for deployment. This shell could be around 1 inch in length and 1/2 inch in width. For easy portability, ignition testing becomes the crucial third phase, determining efficacy and reliability. A ferrocerium rod is typically used struck against the prepared magnesium composite, generating intense hot sparks reaching temperatures of 2000 degrees Celsius or even higher. The goal is to achieve immediate sustained combustion of a prepped tinder material, perhaps charcloth or fine wood shavings. Initial tests might show a success rate of only 6 out of 10 attempts, but with refinement and careful material preparation, this can increase dramatically to 9 out of 10 or even 100% under ideal conditions. The burn time for a single magnesium burst can be brief, just 3 to 5 seconds, yet incredibly hot enough to ignite many common tinder types. Safety measures are paramount during this entire experimental process, including wearing eye protection like safety goggles and working in a well-ventilated area to avoid inhaling any fine metal particles. This innovative method provides a surprisingly robust alternative to traditional fire starters, utilizing readily available materials often considered junk. The amount of force required to strike a spark is minimal, around 10 newtons of pressure. A complete igniter unit, once assembled, could weigh less than 2 grams, making it ultralight for any survival kit. The whole creation process for one usable igniter might take around 35 minutes from the initial tab collection to its final assembly and testing, ensuring a reliable spark whenever needed. It redefines what is possible with everyday discarded items, turning them into a valuable resource with a bit of ingenuity and scientific understanding of material properties. This project truly emphasizes a resourceful approach to wilderness survival or emergency preparedness, where every single item can potentially serve multiple purposes. A tiny speck of metal can erupt into a 2000-degree inferno. This seemingly impossible feat is at the heart of transforming discarded aluminum soda can tabs into a potent fire-starting apparatus. Imagine collecting hundreds of these shiny pieces, perhaps 250 to begin, and carefully sifting for the occasional trace amounts of magnesium, an often overlooked alloy or coating within. Understanding this magnesium concept is crucial, knowing its ignition temperature hovers around 650 degrees Celsius, far below the spark temperatures generated later. The crafting process then becomes intensely methodical. demanding precision. One might meticulously scrape or file the internal surfaces of perhaps 25 individual tabs to painstakingly gather a minuscule but powerful pile of magnesium shavings. This raw material, sometimes just a mere 0.3 grams, must then be carefully consolidated. One method involves compacting it into a small disc. Another secures it to a larger piece of tinder, like cotton, for better handling and direct application. Different collection techniques are explored, like dry scraping or light abrasion, each aimed at maximizing the precious yield. After preparing the magnesium, the actual igniter construction takes shape, often encasing this material within a small protective shell or a cleverly modified tab section. This shell could be around 1 inch in length and 1/2 inch in width, designed for easy portability in any kit. The entire creation process for one usable igniter might consume around 35 minutes from the initial tab collection through its careful assembly. Ignition testing naturally follows determining the efficacy and reliability of this innovative fire starter. A ferrocerium rod is typically employed struck against the prepared magnesium composite, generating intense hot sparks that can easily reach 2000 degrees Celsius or even higher. The goal is straightforward: immediate, sustained combustion of a prepped tinder material, such as charcloth or fine wood shavings. Initial tests might reveal a success rate of only 6 out of 10 attempts, a number that improves dramatically to 9 out of 10, or even 100% under ideal conditions with refined techniques. The burn time for a single magnesium burst, although brief, just 3 to 5 seconds, is incredibly hot, powerful enough to ignite many common tinder types quickly. Safety measures remain paramount throughout this experimental journey, including wearing eye protection like safety goggles and ensuring work occurs in a well-ventilated area to prevent inhaling any fine metal particles. The amount of force required to strike a spark is surprisingly minimal, often around 10 newtons of pressure, making it accessible. A complete igniter unit, once assembled, typically weighs less than 2 grams, making it an ultralight addition to any survival kit. This project redefines resourcefulness, turning everyday discarded items into a valuable tool with a touch of ingenuity and a solid grasp of material science. Every single item, even a humble soda tab, can serve multiple purposes with the right approach. Instant 2000-degree fire appears from nothing. This magnesium tab igniter project redefines emergency fire starting with everyday discards. Ignition testing is where the true power of this method is fully revealed, determining both its efficacy and overall reliability. A sturdy ferrocerium rod typically becomes the primary tool in this crucial phase, struck against the prepared magnesium composite. This striking action generates intense hot sparks, reaching an astonishing 2000 degrees Celsius, or even significantly higher. The straightforward goal is the immediate sustained combustion of a carefully prepped tinder material, perhaps some delicate charcloth or finely shaved wood. Initial rounds of testing might sometimes show a success rate of only 6 out of 10 attempts, a figure that improves dramatically to 9 out of 10, or even a full 100% once techniques are fully refined and ideal conditions are met. The rapid burn time for a single burst of magnesium, though quite brief, usually just 3 to 5 seconds, is incredibly hot and powerful. This intense heat is more than sufficient to ignite many common types of tinder materials very quickly. Throughout this experimental journey, paramount importance is given to rigorous safety measures. This includes consistently wearing eye protection, such as robust safety goggles, to shield against potential sparks or flying debris. Additionally, it is critical to ensure all work occurs in a thoroughly well-ventilated area, specifically to prevent the inhalation of any fine metallic particles, which could pose a health risk. The amount of force actually required to strike a viable spark from the igniter is surprisingly minimal, often around 10 newtons of pressure, making it quite accessible, even for those with limited strength or experience. Once fully assembled, a complete igniter unit typically weighs less than 2 grams, which solidifies its status as an ultralight and essential addition to any survival kit or outdoor gear. This project highlights immense resourcefulness, transforming items that would otherwise be discarded into a highly valuable tool. It truly showcases ingenuity and a solid grasp of basic material science. Every single item, even a humble soda tab, can indeed serve multiple innovative purposes with the right approach and a little bit of scientific understanding. The collected magnesium offers an energy source that is both potent and extremely portable. Developing precise striking angles and consistent pressure makes all the difference in achieving consistent ignition every single time. One could imagine preparing several of these devices for a full 7-day wilderness trip, ensuring multiple backup fire sources. The sheer heat generated is a testament to the chemical potential locked within these common materials, just waiting to be unleashed. The entire process, from initial concept to a successful ignition test cycle, covers many intricate steps, each demanding careful attention to detail for optimal performance outcomes, ensuring consistent, powerful ignition.